Hello, friends. Welcome to Hydraulics and Hydraulic Machines course. In this lecture, let us focus on some more problems related to a single curved vane moving, the jet striking at one end. In such a case, how to calculate the force, how to calculate the work done, power, and efficiency. So, in the previous lecture, we have explained all the formulae that are required to solve the problems related to unsymmetrical vane. And in today's class, we continue the same to understand more about the velocity triangles and calculation of force, work done, power, and efficiency, how to calculate the vane angles, how to calculate the jet angles if not given. So these are the issues that which we discuss in today's problems. Today's lecture focus on some more problems related to a moving vane, jet striking at one end. It's a continuation of previous lecture, right? Let us straight away take the problem. A jet of water having a velocity of 15 meters per second strikes a curved vane which is moving with a velocity of 5 meters per second. The vane is symmetrical. This is very, very important point. The vane is symmetrical and is so shaped that the jet is deflected through 120 degrees. Find the angles of jet at inlet of the vane so that there is no shock. What is the absolute velocity of jet? Jet outlet. Magnitude and direction. And work done per unit weight. So if I observe actually a jet of water having a velocity of 15 meters per second, so straight away I can write data as V1 is equal to 15 meters per second, right? Velocity of vane U1 is equal to 5 meters per second. That is, the vane is symmetrical. This is very, very important. Symmetrical what? This is the vane is symmetrical. So therefore, theta and phi are same. The vane angles are same. So that means it is deflected through 180, deflected through 120 degrees. So therefore, theta plus phi is equal to 180 minus 120 is equal to 60 degrees, or theta is equal to 30 degrees and phi is equal to 30 degrees. This is first conclusion. Then next what? What he wants us to calculate the angle of jet at inlet. Calculate alpha 1. This is what he wants. The second one is what is angle made by what is the absolute velocity of jet. So what is V2 and direction means what is beta. There is nothing like alpha 1, it's only alpha. Beta. So these are the things he asked apart from what is the work done per unit weight. So this is what is being asked, right? So now if I draw the velocity triangles and then understand the problem. So if you take it, right, right, right. So these are the things. So this is the alpha. This angle is beta. So the outlet velocity angle for your reference. This is VR2. This is U2. This is V2. This is beta. This is phi. Right? This is VW2. This is VF2. Right? Here also, if I continue it, then this is VW1. This is VF1. and this is what we call it as alpha, right? So once again, like this is how inlet, this is how next, this is how next, then combined. So this is how it is. So this is V1, this is VR1, this is alpha, this is theta, and this is VW1. This small portion is U1, and this is VF1. So this is what inlet outlet, right? This angle he has given as 120 degrees. So this is theta plus phi. So that remaining is 120. That is O. So coming to the problem, how I will really solve the problem, because the peculiar thing is that in the previous problem I found only basically given alpha and beta, I tried to find out what is theta and phi. Now basically now given theta and phi, how to find out alpha and beta. So first thing is the plate is smooth. So U1 is equal to U2 is equal to U is equal to 5 meters per second. Then second one is VR1 is equal to VR2. So this we make. Now I will take it actually how to go around. Take the inlet velocity triangle, right? If you take the inlet velocity triangle, once again, right? This is the thing. So in this, if I take it, if I represent them by this is A, this is B, right? This is C, this is D. So if I take the triangle ACB, that means this velocity triangle, triangle ACB, if I take it, then applying basically sine rule, because that is the only way, applying sine rule. What can I write sine rule actually? If I see, right, it is first one is if you take what is this angle opposite to V1, this is theta, so naturally this will be 180 minus theta. So V1 divided by 180 minus theta is equal to the first one. I am starting like this, is equal to, then next one is if I take this opposite to this, if I take it, so this is 180 minus theta, this is alpha, then what it should be, all three should be equal to 180 degrees. So if I take it this actually if this uh, angle, if I want to calculate, so how much it will be, so if you tell me how much it will be, basically it will be actually theta minus alpha. Am I right? This is how it will go. So what is this? It I can write AC by AC means straight away I will write AC means U1 divided by, this is sine theta minus alpha. If I put it like this, so then automatically V1 is how much they have given. V1 is equal to 15. 15 divided by sine 180 minus theta. Already sine 180 minus 30. So it is sine 30, because theta is equal to 3. So it is U1 is 5 divided by sine 30 minus, because theta is 30, minus alpha. So all the things are known from this. If you calculate what is alpha is equal to, if you calculate, it is, you are going to get actually alpha is equal to 20 degrees 24 minutes. Please try this. What you have to try, 15 into sine 30 minus alpha is equal to 5 sine 30. Then substitute. Then actually sine 30 minus alpha is equal to calculate. Then basically what is sine 30 minus alpha is equal to this. Then basically calculate what is both sides. If you put sine, then naturally the alpha is equal to, you are going to get around 20 degrees 20.4 degrees. So it amounts to 20 degrees 24 minutes. This is first one. Then similarly, apart from this, so by this one answer I got it. What is alpha? Right? Once alpha is obtained, my next job is to see that how to get actually VR1. Unless VR1 is obtained, we cannot get VR2. Unless VR2 is obtained, I cannot get V2. This is the logic. So how to get, next question is how to get VR1. So this is the thing. So in order to do that same, I will use the same, basically the diagram. Again, triangle ACB only I will take. Triangle ACB. Again, I apply only sine rule only. Applying sine rule. All question problems revolve around this only. Applying sine rule. Then what I will do, if you see it actually. So now VR1 I want. Rather than previous one, if you see, it is AB divided by sine 180 minus theta is equal to, then next one, what is VR1 I want, CB divided by, basically it is sine alpha, right? So if I do it, what is AB is equal to 15 divided by sine 180 minus theta, it is nothing but sine 30 degrees is equal to, what is CB is equal to VR1 divided by sine alpha, sine of 20 degrees 24 minutes. Alpha is not. So from this, calculate what is VR1 is equal to. So if you calculate what is VR1 from this, it is going to be 10.46 meters per second. This calculation is one which you have to practice, because it's not that easy straight away to do in the exam unless you practice this, because if all the data is available, three values are there, only one value you need to find out. So once VR1 is known, VR1 is equal to VR2, so therefore it is 10.46 meters per second. So that job is done. So now once this is done, I will go to then actually the outlet velocity triangle. Outlet velocity triangle. What is outlet velocity triangle? It is EFG. If I draw that, actually for your understanding sake, this is V, this is one, right? So this is V2, this is VR2, this is U2. Then if you take it extend, so this V2 is beta and VR2 is phi, and then this one is VW2, this is VF2. This part is outlet, right? Gone. This is the case. Then in such a case, what are the things actually for us? How it goes out? If I see, it is E, F, G, H. If you take like that, so EF, this is not the way. Generally, we don't do this. Let me correct it. How I go generally. Generally, how we go is this is the way how we go at the outlet. It is E, G, F, H. Right? So EFG is the velocity triangle. I show in color also that velocity triangle easily you can understand. So this one, whatever I am putting in red color is the real velocity triangle, because velocity triangle is a triangle drawn between three things. One is absolute velocity, velocity of the vane, and relative velocity. If these three components are the three sides of a triangle, then that triangle is called as velocity triangle. Once again, note, velocity triangle is a triangle having three sides such that one side is absolute velocity, one side is velocity of vane, and one side is relative velocity. That velocity V, U, and VR, these three together, whatever triangle you make with these sides, that is what we call it as velocity triangle. Right. If you take this as the velocity triangle, again our job is, kindly remember what is our job. Beta is how much we have to find out, and what is V2 we have to find out. These are the two things that are there on our agenda. When these two things are there on our agenda, then if you see at the outlet, basically, if you see what is, for example, if I see VR2 cos phi is equal to, because I want beta, that is why I'm working in that direction. VR2 cos phi is equal to, that is U2 plus VW2. Any dispute? Absolutely clean. Then once that is done, then naturally what is VR2? VR2 is equal to VR1. It is 10.46 cos phi is equal to, we know, 30 degrees, is equal to U2 is equal to U1 and plus VW2. So therefore VW2 is equal to, first answer I am getting, VW2 is equal to, now if I calculate, it is going to be VW2 4.06. See this value first, 4.06. This is 5 and this is 10.46 and this is 30 degrees. This is what I have done first. Then I will go into next. Next, because each one I am trying actually slowly. Then how to calculate VF2 I will try. VR2 sin phi is equal to, VR2 sin phi is equal to VF2, right? So therefore VR2 is equal to how much? 10.46 sin 30 is equal to VF2. Therefore VF2 is equal to, how much we will get actually, it is 5.23. So this is 5.23, so meters per second. This is what I got. Then what is tan beta is equal to, tan beta is equal to VF2 divided by VW2. So what is VF2? 5.23 divided by 4.06, which is equal to how much actually, if I calculate, 1.288. Therefore, from this, beta is equal to Beta is equal to 52 degrees, 10.2 seconds. This is second answer. Once this is over, actually, so next, the second answer he has asked is the work done per unit weight of water. What is the work done per unit weight? It is equal to 1 by G into VW1 basically plus VW2. Why I used plus? Beta is less than 90 degrees. So that's why I used. So now you take it, actually, it is nothing but 1 by 9.81 into what is VW1 actually? VW1 is, again, go to the inlet velocity triangle. It is V1. I have not calculated that. No issues. V1 cos alpha plus VW2, anyhow I have calculated. It is how much actually into U. Well, into VW2 is how much I have done. It is 4.06 into 5. So it is equal to 1 by 9.81. V1 is equal to 15 cos alpha. Alpha is equal to 20 degrees, which we have found out. 40.2 minutes plus 4.06 into 5. If I calculate all this, you are going to get 9.225 Newton meter per second. So this I will stop here this lecture. So because your understanding is more important in this, so this I will stop here and we will take up next part again.
Like, share, and subscribe. Hit the bell icon for more updates.